Welcome to today's deep dive. Imagine you are wiring up a sprawling sports bar, or maybe even a massive stadium. You've got screens everywhere, and they all demand perfect 4K quality. But standard HDMI cables, well, they hit a physical wall. They basically degrade into pixelated garbage after about 50 feet. So how do you get a flawless, uncompressed signal from a hidden control room to a screen on the exact opposite side of the complex? Today, we are tackling that exact distance problem. We are pulling specs from an HDTVSupply product page for a highly specialized piece of pro AV gear. It's the Kramer F676-IN2-F34 input card.
Mm.
Our mission is to demystify the hidden tech that lets massive venues transmit heavy AV data over impossible distances.
Right, because when you hit the physical limits of copper wire, the industry has to pivot to the speed of light. Literally. I mean, we are talking about lasers firing down fiber optic cables. And this Kramer card, it acts as the vital receiver at the very end of that fiber rod. The numbers here are just, well, they're what make it a heavyweight. If you use single mode fiber, which is known as OS1, this card handles uncompressed 4K video at 60 hertz from up to 33 kilometers away.
Wait, 33 kilometers? That's like 20.5 miles.
Yes, exactly. It's a huge distance. Or, it can push 3 kilometers on a multi-mode setup.
Hold on a second. A 30-kilometer difference in range between single mode and multimode. That is massive. If both are just shooting lasers down a glass tube, why does single mode get to run a literal marathon while multimode just taps out after a couple of miles?
Well, it really comes down to the width of the glass core and, the physics of light. Multimode uses a wider core. It is much cheaper to install, sure, but the light waves bounce around off the interior walls of the fiber as they travel. So over long distances, that bouncing causes dispersion.
Ah, so the signal gets muddy.
Exactly, it gets muddy. But single mode OS1 uses a microscopic core and a highly precise laser. The light shoots straight down the middle with almost zero bouncing. That keeps the data packets perfectly intact for those 20-plus miles.
Okay, that makes perfect sense. A narrower pipe and a tighter beam means less distortion. But let's look at the bandwidth for a second, because we're talking 18 gigabits per second of data hitting this card. When a marathon's worth of distance meets a fire hose of data like that, how is this tiny card physically catching that much light and turning it back into video without, bottlenecking?
Right, so it relies on a photodiode to instantly convert incoming photons into electrical voltage. It is literally translating light pulses back into an electrical HDMI signal in real time. But to prevent a bottleneck with that massive 18 GBP's fire hose, the card relies on near-zero latency video chroma subsampling.
Chroma subsampling, so it's compressing the color data.
Yes, exactly. It efficiently compresses the color data, adapting a really heavy 4.4.4 color space to something like 4.2.2, and it does this without the human eye even noticing the difference. That is what keeps the video flowing instantly.
Oh, wow. So the photodiode handles the physical translation of light to voltage, and the chroma subsampling acts like a hyper-efficient traffic cop managing the color data volume. That's wild. But what about the hardware handshakes? I mean, if the control room is literally a town away, how does the source know what the TV at the bar can actually display?
That is where Kramer's IED Pro algorithm kicks in. HDTV is basically the display's identification profile. It tells the source, hey, I am a 4K screen running at 60 hertz. This algorithm intelligently manages that handshake across the fiber link.
So it ensures the screen doesn't just go black because of a resolution mismatch.
Right, exactly. It keeps the whole massive network strictly plug and play. And on top of that, it embeds bidirectional RS-232 data right into that same light stream.
Wait, meaning an operator sitting in a control room 20 miles away can trigger physical hardware, like powering up displays or switching inputs over the exact same glass thread carrying the Dolby True HD video.
Yes, absolutely. This integration completely removes distance from the equation of AV design. The heavy processing and control systems stay hidden away in a centralized server rack, while the display out on the floor, well, it only needs power in this fiber receiver.
That is incredible. So the next time you are sitting in a massive venue, looking up at a crystal clear live feed on a giant video wall, you'll know there is a fiber optic network quietly doing the heavy lifting right behind the drywall. Which really leaves you with something fascinating to ponder. If modular tech like this can flawlessly beam uncompressed 4K video and physical control signals across 20 miles of glass thread, what happens to the physical architecture of our spaces when the screens we look at no longer need to be anywhere near the computers actually powering them?